free body diagram questions on Atwood's apparatus. Atwood's apparatus means that we have two objects that are tied together. The destinies of the two objects are therefore related to one another. Building our free body diagram, we know that this object is going to have a force of gravity exerted downward. That since there is friction in the system, there will be a tensional force. If there was no friction, there would be no force of tension on that string system. Looking at block up here, block 1, we have our force of gravity, we have our normal force, we have our pull force exerted rightward, realizing logically that that pull force exerted rightward is equal to the force of gravity caused by block number 2. That we have a force of friction that slows us down. Alright, now we've got to throw numbers at all of these free body diagram forces. Our force of gravity over here is equal to 0.15 newtons. And therefore our pull force here is equal to 0.15 newtons. Our force of gravity here is equal to 0.6 newtons. Since we're on a horizontal surface, we're not on an inclined plane, there's no elevator or anything like that, there's no awkward pull forces going on at any awkward angles. Our normal force is therefore equal to our force of gravity for block number 1. And solving for the force of friction for block number 1, remember, force of friction is equal to normal force times coefficient of kinetic friction. In this particular case, 0.6 times 0.15 is equal to 0.09. Logically looking at it, we can then determine that the force of friction is equal to this object number 2's force of tension. You are now finished with your free body diagram. Taking a look at it, forces of gravity and normal force offset. Looking at the tug of war between the pull force and force of friction, as well as the force of gravity and the force of tension, we can determine logically that our net force is equal to 0.06 newtons. Now dropping into the second half of the problem, how long does it take the object to strike the floor surface? Once again, anytime we enter this zone of the problem, we're essentially just doing a kinematics problem. But first we have to figure out what our acceleration is upon falling downwards. We can solve for that by setting up our net force experienced by both blocks is equal to your mass times your net acceleration. This is a part that can be a little bit tricky because we've already solved for a net force, but some folks have a rough time figuring out what to plug in for mass. The mass is not the mass of block 1 nor block 2 independently, but rather the mass of both blocks. Their destinies are tied together. The net acceleration experienced by both blocks is therefore equal. It wouldn't make sense for the blocks to have their own independent accelerations. They're tied together. Solving this out, we get a net acceleration experienced by both blocks of, I'm going to call it negative because block number 2 is falling downward. Now we're ready for our kinematics problem upon determining how long it takes block number 2 to strike the surface of the ground. Assuming we're dropped from rest, assuming an acceleration, oh, not acceleration due to gravity, sorry. Knowing our distance that we have to travel. Now it's just a matter of picking the right appropriate kinematic equation. And solving. Time required to strike the ground is 1.58 seconds.